medium problem. Given some numbers, find the number of distinct XOR triples, like take any of them and do XOR. This is not a big problem. This is all n square acceptable. Solution is 150 elements, 1500 elements total. And the solution is brain teaser because it is almost brute force acceptable. The only thing you have to know, or in your intuition, is that when we're doing XOR operation for A, B, and C, if A equal B, then XOR of them would be 0. And that means we can XOR almost all elements in this array is a A, B, C, D, E, F. So all of them are separate results of XOR because we can do A of and A for the first one, and then entire array for the third one, and that would be the result. This is one intuition. So basically we can have all of the items as the result, but we also can have a second order intuition that XOR compresses very much, because imagine we have big all the numbers from 1 to n. This would be the entire array, our array. And when we do XOR of triplets I, j, k, this was a previous day, yesterday problem, they result in is 2 to the power of size of all of these numbers. Why? Because I explained it yesterday. If we have the n, the biggest number has bits set first, for example, highest one bit, and some other bits. It doesn't matter what's here. But if we do XOR operation, we can set any other bit in this numbers. Basically we have the entire sequence of numbers themselves. Plus we have the next bit of the tail, so it is size plus 1. This is a number of XORs, and that means it doesn't matter what your size, so you don't have to do size times size times size. For example, if you have 1000 elements and size in cube would be 1 million, and this is a big number. However, if we have only 1000 elements, then maybe this is not size, it's it's just highest one bit. It's not the size, it's a logarithm size. Okay, so it's just we have size basically for the 1000. Imagine we have 2 to the power 1024. It is 2 to the power of 10, and the number would be 2 to the power of 11. This would be 2048 triplets of XOR operations. So not 1 million, only 2048. And that means after the first, so we have number A to Z, this is numbers, second loop, first loop, and then A to Z, second loop. And we can do X, Y, X, XOR Y, and put them, and this is a pairwise XORs, and we put them into hash set because they're collapsing very much. XOR is erasing operation. Basically, if we have some bits and we do XOR of them, they collapsed very well. And we would have many situations where similar bits collapse it in the same way, but for different numbers. Basically, the hash set result of the pairwise double for loop is not n squared, it's much less. And that means we can use this to do another iteration for this hash set, and we do it multiplying by another iterations of all the numbers, basically another for loop for x in s, for y in n. We're doing a new set of x XOR y, and this would be the answer set. Okay, let's look for code. This is my code that was accepted. I did several irrelevant conversions like compressing initial array to hash set, but this is not the main compression. The compression is this one. So instead of doing inner loop at the third loop, we extracting it to another iteration. Let's look at the shortest version. Okay, this is not the shortest one, this is one shortest. So we're doing build set for of n square results, and do it another for loop, and then do size of the set. And in Rust it gives the same big runtime, almost 1 second. And to make it faster, we can use deduplication at the first, but this is not the fastest. The fastest improvement would be to don't use hash set, just use some bitset or just a boolean array. We have almost maximum number of bits of 2048. This is accepted. And set it. So instead of hash set, put some x. We're doing boolean array of x equal true. This is the same, the equivalent. Okay. And the result for this in Kotlin is only 200 milliseconds. A little bit longer code. And in Rust it is 78 milliseconds for using just hard-coded maximum number of bits. Okay, that's it for today.